All right, in this example, we're looking to identify the particle's path by finding a Cartesian equivalent of this particle and then graph the Cartesian equation and indicate the portion of the graph traced out and the direction of the graph. Okay, so we have here x is equal to t squared and y is equal to t plus 1. So to try to get a sense of this, let's first start with a table, and we will plot just some values from -3, -2, -1, 0, 1, 2, and 3, just to kind of get a sense of how this function is changing. Okay, so we plug in these values for t. You can kind of see the table that I'm making here. Plugging in here, this is going to give us the square for x, so this is going to be 9, 4, 1, 0, 1, 4, and 9. And then likewise, you're going to see the y value is going to be given here. So this is going to be -2, -1, 0, and then 1, and then 2, and then 3, and then 4. Okay, so if we plot these points, then we'll see that this has some sort of shape. So this is x here, and this is y here, and we're implicitly plotting for values of t, but we have x is equal to 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can actually maybe be accurate a little bit here, and there's -2, so this is 9, -2. We have over here at 4, 1, 2, 3, 4. We're down here at -1. And then at x equals 1, we're at 0. And then at x equals 0, we're at 1. So it looks something maybe like that. And then at x equals 1, we're back here at 2. And then at 4, we're up here at 3. 3. Okay, and then over here at 9, we're up here at 4. Okay, so if you kind of see, this does look like it's probably some sort of parabola on its side. Okay, and so just kind of loosely connecting the points there. Okay, so all right, if we look at the parameterization that we have here, I could solve this one for y, and I get x squared is equal to, not x squared, sorry, that's a t squared, is equal to x is equal to t squared. But if I solve this for y, or for t, I get y minus 1. So that's going to be y minus 1 squared. That's what I was trying to write. And so this does then have the form of x equals y minus 1 squared, which is exactly what you see here. It's a parabola on its side, or you could say both branches of the square root of x. If we look at the values of t and how this function is growing, we started down here at t equals -3, so that was here. And then we went this direction as t increased. So that then tells us that this is the direction of the flow of this graph. Okay, so I think that covers all of the pieces that we were looking for, and I hope that was helpful, and I'll see you in the next video.